So let's talk about sedimentary rocks. Here are our learning goals. We're going to explain the 4 steps in the formation of a clastic sedimentary rock: weathering, transportation, deposition, and cementation. We're going to talk about examples of clastic, chemical, and biochemical sedimentary rocks. And we're going to describe some of the features of sedimentary rocks: stratification, fossils, ripple marks, and mud cracks. Alright, the crust of the Earth is 90% igneous rock, but the crust is mostly covered with sedimentary rocks. Kind of like this piece of carrot cake. The vast majority of this cake is cake. There's a little bit of icing on the top that covers it. So if we were looking down from above, we wouldn't see the cake itself, we'd just see the icing. That's kind of like the crust of the Earth. The crust of the Earth is mostly all igneous rocks, and it's covered with a thin layer of sedimentary rocks. Alright, so sedimentary rocks form through the compaction and cementation of layers of sediment. So we have rock particles, basically, that get deposited somewhere and then crunched together and cemented. So let's see how that happens. Alright, there are 3 types of sedimentary rocks. They're what we call clastic sedimentary rocks, chemical sedimentary rocks, and biologic sedimentary rocks. We're going to talk about clastic sedimentary rocks first. Clastic sedimentary rocks are made up of fragments of other rocks, rock particles. Okay? Those particles might be the size of boulders all the way down to microscopic flakes. Right? These little microscopic flakes down here are clay particles that make up sedimentary rocks, and you don't see too many sedimentary rocks made out of boulders this size, but sedimentary rocks can be made out of particles of rock of any size. So here are the 4 steps in making a sedimentary rock. The first one is weathering and erosion. Then that breaks rocks into particles. Those particles are transported, they're deposited, and then they're squished together and they're cemented. So this is clastic sedimentary rocks we're talking about. Alright, so weathering and erosion. Rain, wind, waves, ice, even plants are constantly breaking rocks down. Rocks look like they're permanent when you see them outside, but they're constantly getting smaller by the day. Not significantly smaller every day. You can't see them change usually, but it's happening, and they're being broken down into small pieces. Those pieces then get transported, almost always by water, sometimes by wind, occasionally by ice, usually water. And when water transports rocks, they become rounder and smoother the further they're transported. When rocks are being transported in a river or a stream, they bang together. And when they bang together, they knock off the sharp edges, and they get rounder and smoother. Right? The longer they're transported, the rounder and smoother they get. It's one of the principles of understanding sedimentary rocks. So here's a particle that may have been recently broken loose from a rock through weathering, and as it's being transported by water and banging around, these little edges keep getting knocked off, and the particle gets rounder and smoother. And eventually, if it's transported a long distance over a long time, it'll end up relatively round and smooth. Now, water will transport the sediment, and eventually water will deposit the sediment somewhere. So imagine sand moving down a river or a stream. It reaches a lake. The water slows down. It stops moving. And the sand and the sediment that's been in the water drops out of the water and collects somewhere. It gets deposited. And water also sorts sediment by size. The faster the water is moving, the larger particles it can move. As the water slows down, those larger particles begin to fall out and be deposited along the way, until finally just the smallest, tiniest little particles are still being transported by water. Now, eventually, as those materials get deposited somewhere, they build up in thick layers and they squish each other, they compact each other. And then as water percolates through these materials, it leaves behind minerals like silica or calcite, and that glues the grains together. Okay, if we look at this microscope picture of a classic sedimentary rock, here's a rock particle, sediment, here's some more, and this blue stuff in between is a mineral that's glued it all together. Now let's look at some types of classic sedimentary rocks. One is called a conglomerate, and if you look at it, it has large rounded fragments. Now these fragments aren't all spherical, right? Some of them have lumps and humps on them, but if you look at the edges, these are all smoothed off. They're rounded. There's no jagged edges. Maybe an occasional one here or there. These fragments range in size from boulders down to the size of little pebbles, gravel. Another type of classic sedimentary rock is called breccia. Breccia is essentially the same thing as a conglomerate, except these particles that make it up, these rock fragments, have sharp angular edges on them because these particles haven't been transported as far by water. They haven't had a chance to get rounded and smoothed. So they're still angular. They get deposited somewhere and compressed and cemented together. And again, the particles in a breccia can range in size from gravel to boulders. Sandstone is another classic sedimentary rock. It's made up of sand-sized particles, right? These are particles about the size of the head of a pin, and oftentimes it's made out of quartz, right? Think of beach sand that's been squished together and glued together. That's what sandstone looks like. If you were to touch it and rub your finger across it, it would feel just like sandpaper. And another classic sedimentary rock is called shale. Shale's made out of clay-sized particles. These are particles that are the size of the particles in the type of flour, the stuff we bake bread out of. These are very, very tiny particles, right? Can't see them with your naked eye. So we talked about conglomerate that has boulder to gravel size rock particles in it. Breccia, same thing, except the particles aren't rounded. We talked about sandstone. The particles in that rock are going to be pinhead size, sand grain size. And finally, shale, which has the smallest particles of all. Now, shale is an important resource because shale often contains oil and gas, and these are areas of the country that contain large amounts of shale, and guess what? These are areas where you're going to find a lot of oil and gas. Now we also have chemical sedimentary rocks. Chemical sedimentary rocks are formed when minerals precipitate from water through evaporation. So these are going to be minerals that we studied that are evaporites. So things like halite, gypsum, calcite. And this is the kind of environment where a chemical sedimentary rock would form. Think about out west where we have these large areas where when it rains it fills with water, it dissolves minerals and carries them to that area, and then that water totally evaporates in the summertime and leaves behind these minerals like halite, calcite, and gypsum. And then there are organic sedimentary rocks, biologic sedimentary rocks. These form from the remains of plants and animals, right? And of course, coal is a great example of that. Coal is formed from the remains of ancient plants that lived in a swampy environment long ago. And this is what it would have looked like. The water in this swamp would have contained very little oxygen. When this plant material died, it fell into the water. It would accumulate down at the bottom. There wouldn't be much oxygen at all there, so it wouldn't decay. Things couldn't live without oxygen and feed on the dead material, so there weren't a lot of decomposition organisms down there to decompose these things, and so they built up over time and formed coal. Another organic sedimentary rock would be limestone. Limestone forms from the shells of plankton, basically, right? Plankton are microscopic plants and animals that live in the ocean. They form shells from calcite that they take out of ocean water. They form tiny little shells, and when they die, those shells sink to the bottom of the ocean, and they build up in huge layers sometimes. They're primarily calcite, right? Remember, calcite reacts with acid and fizzes, right? So here's some examples of the tiny little shells that might make up a limestone. And here are the white cliffs of Dover in England, which contain huge amounts of limestone. Now, sedimentary rocks have some features. One of them is called stratification. Sedimentary rocks are laid down in layers we call strata. And we're going to talk about those strata when we talk about geologic dating. So it's going to be really important later on. Now, sometimes sediments change, and the sediments that are brought to an area and deposited can change over time and form different layers of different rock, one on top of the other. And each layer can be separated by what's called a bedding plane. And this is a great example of layers of sedimentary rock that were laid down over eons. And if you look carefully, you'll see that these layers are different types of rock. So the environment changed over time, the types of rock particles that were brought to the area and were deposited changed, and so we get a change in the type of rocks that are present. Now, sedimentary rocks can also contain fossils. Igneous rocks don't, metamorphic rocks don't, only sedimentary rocks. Fossils can be the remains or traces of living things. They could be footprints, they could be burrows, or they could be bones, like this T-Rex, or a fish. They could be leaves, they could be stems of plants, they could be shells of animals, right? Like here's a trilobite. You could also have seashells, right? Here I am holding some dinosaur bones. And we can also find things like ripple marks and mud cracks in sedimentary rocks. This rock formed in a shallow sea long ago. As the water moved across the bottom of the sea, it caused these ripple marks. More sediments were laid down on top of them, and they were frozen in time. And these are some mud cracks.